Greetings, ladies and gents, and welcome at Same Maths and Science Club. Today we are starting with the trigonometry. So this is a topic that you find in term 3. It's a very short topic and a very interesting one. So what we're going to do, of course, in this video is that we're going to do a revision from the work that we did in grade 11. So I'm sure you're familiar with these three trig ratios. So that's the sine, cos, and of course tan. Now, of course, if now suppose you are standing, of course, on that vertex, which is B. So this, of course, would be, of course, the side opposite that vertex. So this would be the side opposite to theta. So AC in this case would be the side opposite. And of course, we know that the longest side in this case is given to be the hypotenuse. And also the way you can note that is that it is always opposite that 90 degree angle there. So this that's the hypotenuse. And of course the side BC would be the adjacent. So that's the side next, of course, to theta. So this would be the adjacent. I hope I wrote that correctly. So of course, I'm sure you know that the definition for sine, in this case, that's the opposite over the hypotenuse. So if I'm standing, of course, on that vertex there, the opposite would be AC, right? So this would be opposite of course, the hypotenuse. So if we are using, of course, this the right angle triangle that we have there, so opposite would be that side AC, and the hypotenuse in this case would be AB. And of course, for cos, that's the adjacent over the hypotenuse. So this would be the adjacent of course, the hypotenuse. And again, in terms of that triangle, that would be BC all over AB. And for tan, of course, it's the opposite again. If we are standing still, of course, on theta in this case, which is there. So in this case, it will be opposite over the adjacent. So in this case, this would be, of course, AC all over let me just put that there. So that would be, of course, AC over BC. So this would be BC there. So that would be what we learned in grade 11. So what we're going to do is that we're going to do a few questions, of course, to consolidate what we did last year, which is in grade 11. But what I need you to note about these three trig ratios is that they are only applicable in a right-angled triangle. So that's the most important thing that you need to note. So these three, of course, three trig ratios, they are only applicable in a right angled triangle in this case. So that's the most important thing that you need to note. And also, of course, the Pythagorean theorem. So we can only use those four, of course, rules, which being the sine, cos, tan, and the Pythagorean theorem. So we can only use those in a, of course, in a right-angled triangle. So as soon as it is not a right-angled triangle, we cannot apply this. So that's the one important thing I can say. But now someone might wonder that what happens then if it is not, of course, a right-angled triangle, because the reality is that in real life we hardly have any, right-angled triangle. So I would say this is actually where the grade 11 work really comes in, because we are going to learn, of course, the rules that we are going to apply in this case in triangles that are not, of course, the right-angled triangle. So we're going to learn three laws. So of course the cosine rule, of course, those are three rules. So that's the cosine rule, the area rule, and also the sine rule. So those are the, of course, the rules that we're going to apply in, of course, in triangles that are not right angled. So what we are going to do is that we're going to do 3 questions. So what I would suggest is that you pause, you try them out, and then of course you can watch the solutions. So they say given a triangle PQR with PQ being 7 units and QR is in this case being PR, I should rather say, being 9 units, and QRP being theta. They say calculate the length of of QR. So this would be the length that they want us to calculate. Of course, you can already see that this is the hypotenuse. Of course, that QP in this case would be the opposite if you are standing, of course, on that side. But most of you can show you already see that we can actually apply the Pythagorean theorem, so which says the hypotenuse in this case squared is equals to the sum of these two sides squared. So the Pythagorean theorem says, of course, r squared is equals to x squared plus y squared. But you must not forget, you must credit the legend that came of course with this theorem. So that would be Pythagoras, or you can just write that as Pyth. And of course we know that r squared would be the longest side. That's what we are looking for, which is QR. So in this case this would be QR squared, which is equals to, of course, that would be 9 squared plus 7 squared. So in this case you can just add those two. Of course that's 9 squared would be 81 and 7 squared would be 49. So you add those two are the value that you're gonna get, and then you square that. So when you square that, of course, when you square that, you're gonna get a value of 11 point, so that's 11.4. So that's 11.4 when you round it off. Of course that would be units. So that would be that length there, which is the hypotenuse. So that's 11.4. Now if you got an answer that was less, of course, than either one of those sides, now you would realize that of course that can't be true, because we know that the hypotenuse is always, of course, the longest side on a right angled in a right angled triangle. Now they say that calculate the size of theta. Now you from this point you can use any of the 3 trig ratios. You can either use the sine, cos, or the tan trig ratios. But what I like to do is that I always try to avoid the side that I have just calculated, because in this case what happens now if I make an error in this case. So I would actually just continue with that same error. So what I'm going to do is that I'm going to use the tan trig ratio, because this of course the tan trig ratio in this case would contain the size that they initially gave me. So that would be tan of theta would be equals to, we know that tan, of course, that's opposite, which is actually just 7 over 9 there. And to find, of course, theta, you just press shift 10. Of course you're gonna get of course arc10, which is 10 to the power of -1, and of course you put that ratio there, which is 7 over 9. Now of course if you put that on your calculator, what you're going to get is that you're going to get 37.87 degrees. Now if you had used the sine or cos, you would have found a value, of course, that is closer to that. Now the reason for that would be because of the roundings that we did in this case. So you, of course, you would still be marked correct in this case, because that's the answer that you got. Now they say calculate, of course, the size of of course of PQR. So that would be that angle there. Now we have already found that this side in this case that was 37. So that's 37.87. Now we are looking for Q, which is the third angle. So in this case we're just gonna use the sum of the interior angle of a triangle. So in this case, this would be, of course, that would be Q, which is PQR, which is what we are looking for. So that's PQR plus, of course, that 90 degrees, that there plus 37.87, and that would be equals to what? To 180. So that would be 180 there, and you must give a reason that that's the sum of interior angles, yeah, of course, angles in a triangle. So that would be the reason that you give there. So in this case, we know that P, of course, Q R would be, of course, 180 minus 90 minus that 37.87, and if you put that on your calculator, let's say, so that would be, of course, 90 minus 37.8, that's point, so that's 37.87. so what you're going to get is that of course that angle there will be 52.13 degrees. So that's the value that that I got there. So that would be, of course, the size for that angle there. Now you could have just chose to even use any of those ratios. So you would be looking for that, and you have all of the sides. But again, this was actually the easiest, because now we have two. We are looking for the third angle in this case. So we're going to do the second question. Now again, I would hit pause, try it, and then of course you watch the solution. They say in the diagram below, AB is equals to 30, that's 30 meter, and of course DAB, which is the angle, they say that's 21 degrees. So that would be that of course big angle there. Is, of course, it's already indicated there, and they say that CAB, which is that small angle there, that's CAB, they say that's 15 degrees. They say that BCD is a straight line, so it's not drawn to scale. Now they say calculate the length of AD. Now where is AD? Of course AD would be that hypotenuse. Of course if I'm using, of course, that 21 degrees, so this would be the side opposite, right? And then this would be the adjacent, but this one here, it would be, of course, the hypotenuse, right? When I'm looking on that big of course right angle triangle. So when I'm looking on the smaller one, which is BCA, so in this case that would be the angle that I get, which is 15, and the hypotenuse in this case would be CA or A, or of course CA or AC, and then the opposite would be BC, and then of course the adjacent will still be AB. Now they say that we must calculate AD. Now AD is in the bigger triangle. So in this case, in the bigger triangle, we have that of course that angle there to be 21. So that so in this case, we are looking for the hypotenuse. We have an angle, but what else are we given? We're given the adjacent in this case. So in this case, the trig ratio that we are going to pick must have the hypotenuse, which is what we are looking for. It must have one of the given side. But which side are we given now? We are given, of course, the adjacent. So in this case, we are going to use the cos ratio. So in this case, this would be cos, of course, of 21 degrees, because we are looking in the bigger triangle. So this would be cos of 21 degrees. This would be equals to, of course, we know the adjacent in this case is 30. That would be divided by AD, which is what we are looking for. Of course, to find AD, what I would do is just to multiply by AD on both sides. So that would be AD, and I would do the same on that side. So that would be AD. So what I will get eventually, I will get AD multiplied by cos of 21. That would be equals to 30. And of course, I'm looking for AD. So in this case, I would divide all of that by cos of 21. So that would be cos of 21, and what you would get, so again we have of course, so that would cancel with that, so we'll be left with AD being, of course, 30 divided by, of course, cos of 21. Now, of course, from that point, what you would do is just put again that whole thing there in your calculator, and what you're going to get would be 32 point, of course, that's 0.13. That would be meters. Again, of course, that AD must be big, of course, than AB, because that's the longest side that we have. And then they say that calculate the length of CD, where CD, so CD would be that length there. They say if it is further given that BD, in this case, this whole length is 11.5 units. Now, if you check that side that they said we must calculate, in this case, so that side would be in that smaller triangle, which is not a right angled triangle in this case, so we can't work on that triangle. But what you need to notice that they gave us this whole length there to be 11.5, right? So we know that, of course, that whole length there is made up of CB and, of course, DC. So what I'm going to do is that I'm going to calculate the length of BC, of course, of BC. So if I know that length there, I know that this length plus that one must give us that whole length there. So what I'm going to do is that I'm going to calculate, of course, that BC. Now again, I'm going to be using the smaller triangle, which is 15 degrees. So in this case, I'm looking for the opposite. I have the adjacent. So in this case, I'm going to use the 10 ratio. So in this case, this would be 10 of course of 15. That would be equals to the opposite, which is BC, divided by, of course, that would be the adjacent, which is 30. And again, to get BC by itself, I'll just cross multiply in this case. So BC eventually will become 30 multiplied by 10, of course, of 15. If you put that on your calculator, let me just see what we get if we put that in our calculator, and you would get a value of 8.04. Now in this case, you need to put all your decimal, because that's not the final answer. So in this case, I'm just gonna store that value. So we say that that would be 30 multiplied by 10 of 15. So I'm going to leave that value there. So that's the value that I got there. So what I'm going to do is that I'm going to just store all of it in this case. So I'm going to use it. Now you can't round off until if it is the final value. So in this case, so again, we got that side BC, this portion there, to be 8.0 and some other decimal. But we know that, of course, BD that's equals to BC plus, of course, we are given that to be of course, that plus CD. Of course, they gave us BD to be 11.5. That would be equals to BC. We said that BC in this case that was 8.038 and some other decimal plus, of course, CD. So in this case, to get CD, in this case, that's what they want. So it will be just 11.5 minus 8.038 and some other decimal. And if you do that, so that's 11.5 minus answer. So you'd get a value of 3.46. So that will be the value that you get, of course, for CD. Now, one thing I must advise is that you must not round off until until it is the final answer. In this case, if you are still working on the same question. So in this case, this would be, of course, meters, and even that one. So that's of course, the second question. We have the third, which is the final question. Again, I would hit pause, I try, and then of course I watch the solution. They say in the triangle below, QS is equals to 7 meter, and QR I mean PR in this case, which is that they say that's of course that's 21 meter. They say the angle of depression from the top of the pole. So in this case, we have this pole there. So that we have, so this would be, you know, that angle of depression there. So they say, of course, from the top pole to point P. So that would be, you know, the angle of depression. And they say that it is 47 degrees. And then they say that RQP, that's theta there. Now they say write down the value of theta. So the value of theta in this case would be 47. Now if that's, of course, that's the angle of depression there, so that would mean so we would have a horizontal line there. So if that line, of course, is horizontal, of course it would be, you know, these two lines in this case, they would be parallel. So in this case, we know that angles of course, so that and that would be equal, and the reason for that would be the alternating angles, because this line here would be they would be parallel in this case, because they, so if this is the ground, and then we have, of course, another, you know, horizontal line up there. So in this case, these two, so the distance from, of course, let's say from this point here, let's say if we extend that side, so let's just extend that. So this distance here would be equal to whatever distance that we have between, you know, these 2 points, from this point Q until R, rather I should say, until, of course, to that point there. So it is, of course, the distance, of course, from this horizontal line, from this side, from of course, I would say Q PS, it would be, of course, equal on all, of course, these parts from that point until all, of course, to that side, because they say these lines, of course, they are parallel. In this case, they would be parallel. So in this case, theta, of course, theta would be equals to 47 degrees. So in this case, the reason for that would be alternating angle, alt angles. So in this case, we know that, of course, that line there, let me just, you know, note it as, you know, Z. So in this set, in this case, so ZR would be parallel to what, to PQ. So that would be PQ there. So in this case, that angle there would be 47 degrees. So that would be for that angle there. So they say calculate the length of RQ. Now RQ would be, of course, that length there. Again, you can see that that is a right angled triangle. So in this case, we are looking for the opposite. We have that angle there. We are looking for the opposite. We are given the hypotenuse in this case. So in this case, any trig ratio that I can pick must have the opposite, and of course what I'm given, the hypotenuse. And so in this case, you find out that would be the sine trig ratio. So in this case, it would be sine of 47. That would be equal to, of course, the opposite, which is that RQ, that divided by 21. And of course, to get RQ by itself, because I would cross multiply there. So in this case, RQ would be, of course, equals to 21 multiplied by sine of 47. Now if you put that on your calculator, again, let me just put that on my calculator. So that would be, they say that's, so that would be 21 multiplied by sine of 47. So you would get 15 that's 15.36. so this case, that length would be 15.36. So that would be, you know, the length that you would get for that RQ there. So the last question, which they say calculate the size of S. So S would be this angle there that we have there. But now what we have so far, so we have that length there to be, so we found that to be 15.36. So that's 15 there. So it's kind of, you know, yeah, I can't actually, let me just remove that. So that's 15.36. So that would be that length there. So if you look, of course, in that triangle there, of course, if that's 90 there, so this, of course, angle there would also be 90. Why? Because we know that angles in a straight line add up to 180. So 90 plus 90 in this case would give us 180. So we are looking for S, which is that angle there. But what do we have in that triangle there? Now, what we cannot do is to use that bigger triangle, because that's not a right angled triangle. So far we can only work in the triangles that are right angled triangle. So in this case we have of course we look in this triangle that we have here. We have the opposite. Of course, if we are standing there, we have that opposite, which is RQ, and we are given of course the side, which is QS. So in this case of course that would be the adjacent. So in this case I'm going to pick the trig ratio of 10, because it has the opposite and of course the adjacent, and I'm looking for the sine for that angle there. So in this case I'm going to say 10 of course of S would be equals to, so the opposite in this case would be 15.36, and the adjacent would be 17. And of course to get S, so again you do the same thing. So it would be 10, of course arc10, it would be arc10 in this case, so that would be 15.36. divide that by 17, and what you get for that would be of course 42 point actually that's, if you round that off, that's 0.1. So that would be 42.1. So that would be 0.1 degrees there. So that's the end of today's session. So this was just a revision from the work that we did in grade 10. So what we're going to do is that we're going to look, of course on the next video that we're going to produce, we're going to look at the sine rule. Of course that rule only works in triangles, of course, that are not right angled triangle. So that's what you're going to look in the next session. So if of course you liked this video, be sure to like and also subscribe so that and hit that notification bell, so that when the the next session or the next video comes, you'll be the first to be notified. But otherwise this is the end of today's lesson. Thank you.